Jesus Christ.
Yeah, thanks for all coming out. I didn't drive all the way up from San Diego this morning, just from Santa Clarita, so it's actually a pleasant drive up there. It's quite nice. I enjoyed it. Yeah, thank you, Alicia. I am Cameron. I'm from the Xerces Society. Just to show of hands, who before this event heard of the Xerces Society for Invertebrate Conservation? Interesting, yeah. One of our Pollinator program co-directors likes to say that the Xerces Society is one of the largest conservation organisations that no one's ever heard of. We're a team of probably 50 odd people at this point, growing fairly steadily. Started back in the 1970s as a lepidopteran conservation organisation, named after the Xerces blue butterfly, which was the first butterfly species to go extinct through human causes. It occurred up in the Presidio area of San Francisco there, and that's how we got our name. Since then, we've sort of grown and expanded our scope a fair amount. We now focus on invertebrates in general, typically invertebrates on, terrestrial invertebrates and freshwater invertebrates. We don't go into the marine realm. Plenty of other people doing that kind of work. These are the 4 programs that Xerces focuses on. Actually, there should be a 5th program added to this, which is a relatively recent addition. We've just started an urban program. We merged with BC, Big Campus USA, fairly recently, and so we're doing more and more work in urban areas as well. But the other 4 programs, we've got an aquatic conservation program. They focus on all manner of aquatic invertebrates, freshwater mussels, a lot of work on freshwater mussels. Freshwater mussels are probably the most imperiled group of invertebrates out there. The Endangered Species Program focuses on creatures like the monarch butterfly, bumblebees, and all sorts of other endangered species. Pesticide Program that works quite a lot with the Pollinator and Ag Program. The Pesticide Program works to analyse pesticides, their risk to invertebrates, develop all sorts of guidance, workshops and all sorts of things like that around pesticide use. And the Pollinator and Ag Program, which is the program that I fall under. It's the largest program within Xerces. Largest being 25 odd people. The Pollinator program is spread across the country. I'm based in San Diego. We've got folks in the Central Valley, California, in the Midwest, in the Northeast, the Northwest, all across the country. We've got a really good relationship with the Natural Resource Conservation Service. So we've got partner biologists in offices across the country as well. And so we've got that NRCS work going on. We've also got a big part of the work we do is working with corporate farms, corporations and their supply chain farms. And that's a lot of the work that I do. I'm also the Be Better Certified Coordinator. Be Better Certified is a certification, food and farming certification program we rolled out last year. It's fairly new. It hasn't actually shown up in the marketplace yet, but we're working with a whole bunch of farms across the country to get certified, and hopefully we'll see the seal on some packages coming up in the not too distant future. So we do some work. Our work, this sort of just outlines what our work is, which I've spoken about. A lot of it is to do with on-the-ground restoration work. We do a lot of advocacy, we do a lot of teaching, things like this. We try and get out and speak to people as much as possible about invertebrates and the plight of invertebrates. And we work, up at the government level through the NRCS and things like that as well, and try and change policy and that sort of stuff around invertebrates. And so why do we do this? Invertebrates, insects, play a huge role in many systems. All of these things, plus a few, and invertebrates and insects in the terrestrial realm are probably some of the most important creatures in the way of pollination, in the way of predators and prey, definitely prey for many other species, lizards, birds, all sorts of things. What I'm going to focus on today is pollinators. I work Pollinator program. It's what I do every day. I'd like to talk about all these other things, but it's, just to keep us on track, I'll be sticking with pollinators today. So insects as pollinators. Research published a few years ago stated that around about 85% of all flowering plant species rely on some kind of animal for pollination. And the vast majority of that is done by insects. And of the subset of insects, a lot of that work is done by these guys here, bees. This is a little sweat bee here, which I'll talk about a little bit later on. So they're critical to moving pollen amongst plants, critical for 85% of all plant species out there, which is an amazing number, and it just speaks to the importance of these creatures out in ecosystems, your garden, farms, wherever they're found. And so, another study done a few years ago stated that around 35% of all crops produced worldwide rely on pollinators to set fruit. Pollination varies from, completely dependent on pollinators, almonds, crops like that, to being mildly dependent. So it's across that spectrum, 35% of fruit and vegetables that we eat rely on pollinators. And that, they put a value on that. I think that's a fairly conservative value there. It's probably more than that. This study, I think, was published around about 10 years ago now, so it's probably a lot higher than that. Yeah. And those fruits and vegetables are, the fruits and vegetables that we get a lot of our nutrients, vitamins and minerals from. So really important to our diet as well. This was a couple of pictures put out by Whole Foods a few years back, basically showing the world without pollinators and the world with pollinators. And it's a complete produce section at the supermarket if you went in there without pollinators. So they're pretty important to us. So now I'm going to switch gears a little bit. I'm going to talk about pollinators and some of the issues that are affecting pollinators. A lot of what we do at Xerces is trying to work with people to change practices, educate on some of these issues. And it's a big part of the problem with insects globally. We're seeing huge declines. This is a study published last year out of Germany. So it's not just the US, it's all over the world. A 30-year study sampling biomass of insects in nature reserves, and they found a 76% decline of biomass in nature reserves in Germany over those 30 years. Which, when you think about 3/4 of all the insects in that system, that's 3/4 of the feed for your birds and your mammals that rely on 3/4 less pollinators. That's, across the board, that's just a huge chunk of services that have disappeared and biomass out of the system. This was a study also published last year by some folks over at the University of Vermont. And this is just modeling native bee abundance across the US. So the purple areas are the areas of high bee abundance, wild bee abundance, and the areas in yellow are the areas of low bee abundance. So if you look at this, you kind of say, where are we growing food? Where do we as people need these wild bees the most? And it's in these areas like Central Valley, California, the Imperial Valley, Willamette Valley, and Oregon, all across the Midwest, where the majority of our food is grown. So there's a real sort of mismatch with where bee abundance is and where we actually need it to be. And so when we talk about bees, the first bee that comes to mind is the honeybee, Apis mellifera. I'm sure all of you have been hearing about honeybees and colony collapse disorder. Started around 2006, 2007. Commercial beekeepers started reporting huge winter die-offs or disappearances of bees from their colonies, up around 40-odd%. But the problem, I guess, had been going on for a lot longer than that. Probably started back around the time of industrial agriculture, around the 50s, around the end of the Second World War. Since then, there's been about a 50% decline in the number of managed honeybee hives across the country. And in that time, the amount of farmland requiring services from those honeybees has doubled. So this chain, where does that what does that mean? There's a problem of beekeepers themselves are really hurting from this. They're working hard to split their hives come spring, meet their contracts with growers. You know, you've probably heard the story of 90% of the beehives in the country come to California in the spring. So these growers, the keepers lose their bees through the winter months, and then they've got to work as hard as they can and try and meet their contracts, split their colonies, get their colonies over to California to pollinate the almonds in April, which is really early in the year. Wake these bees up for most places to move over. And so because of things like that, that's where I guess a lot of the issues have been coming from. Bringing all these bees together in one place, spreading diseases. This picture here is a good thing to show the varroa mite. Varroa mite was introduced from a species of honeybee over in Asia, from Asia back in the 80s. The varroa mite, you can see how big it is. If you compare this to us, it's the size of a tick, basically the size of a dinner plate, and you're stuck on your back, and these bees are flying around. And this is not only sucking blood, but spreading vectoring diseases and stuff as well. So it's caused some huge issues, and it's only kind of a small part of the problem. Habitat loss, pesticide use, all these things are kind of factors in the loss of honeybees. And now, honeybees, I put this up there just to talk about honeybees a little bit. But Xerces, we don't necessarily do too much work in honeybees. There's lots of folks researching honeybees across the country, a lot of work going on, a lot of great work going on into honeybee research. What we do is try and focus more on the native or wild bees, of which bumblebees are a prime example of just how badly they're doing as well. So bumblebees, I think probably the biggest risk to bumblebees was the use of commercial bumblebees in open field pollination. Bumblebees are really effective pollinators of things like tomatoes and blueberries. I'm sure you're all well aware of that. And so bumblebees it was worked out there's a couple of species in the US that were really good to domesticate. And so it just so happened that the Dutch are actually really good at rearing colonies of bumblebees. So we sent some bumblebees over to Holland, and they came back with various diseases that then, through open field pollination with these bumblebees, managed to spread these diseases into our wild populations. And since then, we've just seen a crash of bumblebees. There's around about 50 species of bumblebees in North America, and about 30% of those bumblebees are all on the verge of extinction.
Is there any reported resistance to the bumblebees adapted to these diseases? It's been a while.
Yeah, there's work going on that. I'm not sure. I mean, there are populations of the western bumblebee in particular. There's these populations that are still doing fairly well, and so there's a thought that these sort of small populations that have survived have some sort of resistance to those diseases, but I'm not sure about. I don't know how much more work's been done on that. To look into that. And so, just as an example up here, these bumblebees, Franklin's bumblebee is a bumblebee that's native to the Oregon-California border. Hasn't been seen in 10 years. The rusty patch bumblebee, you might have seen in the news last year, was the first bee in the mainland US to get on the endangered species list, which was pretty amazing through work that Xerces did to petition that. The western bumblebee was once the most common bumblebee in the western half of the US, and now it's pretty much gone on the landscape. It occurs in just a few little patches on the Rocky Mountains up in the northwest, but it's pretty much just, you just don't see it anymore. And so what that means is that, I guess, the diversity of bumblebees, there's still bumblebees out there, although it's not a great bumblebee area. Wetter, colder climates are sort of more conducive to bumblebees. But bumblebees are still on the landscape, it's just the diversity of those bumblebees is greatly shrunk. It seems like there's a sort of a group of closely related bumblebees that are more susceptible to these diseases. And that's what these 3 or 4 fall into. So why do we care so much about bees? I've spoken a little bit about this and how important pollinators are in general. Bees and native bees are just fantastic pollinators of plants. They split off from wasps 120 odd million years ago around the rise of flowering plants, and they split off. Well, there's different schools of thought. They split off because of this this resource that became available, the pollen and nectar. So they became pollen and nectar specialists, and as a result of that, they are just fantastic at moving pollen between plants. And so this, I'm just going to talk a little bit about the diversity of bees in North America here. I think there's roughly 3,600 species of native bees. So we know the Apis mellifera, the honeybee. Everyone kind of knows that bee, but there's so much more to the picture. There's bumblebees, but then there's just this amazing diversity of wild bees out there as well. So if you look at these bees here, this bee is not actually this bee, this is not the cell. This is a carpenter bee, which you probably see around the place, Pollinator, Californica. A big bee, probably about this big here, buzzing around, chewing when you're wood and that sort of stuff. And then this is a tiny little mining bee here, a little padilla, which is the size of an ant. Tiny, tiny little bee. Wow. And so within bees, there's kind of four main groups. And so the first group, which I've spoken a little bit about, are honeybees, which are truly social bees, and that's how they have to be kept in a hive. And the hives are perennial in nature, and they occur across multiple years. A queen can live, 3, 4, 5 years within a colony. And there's bumblebees, which are also social in nature, although the bumblebees, the colonies aren't perennial like honeybees. At the end of the season, the female bumblebees will fly off, find a burrow or somewhere to overwinter, and then come out at the start of the next year in the spring, and that's when they'll start to build their colony up. Then there's two types of these other bees. The other bee groups are the solitary bees, of which the vast majority of bees in North America and the world fall into. And they are the tunnel nesting solitary bees and these ground nesting solitary bees. So I'm going to just talk a little bit about the ecology of these other three groups that are here. So this little pictograph of the bumblebee life cycle here just gives you an idea. So we have the female that's gone off and found somewhere to go through the dormant season, the winter, and she emerges early in the spring and starts to forage herself. She goes and finds a mouse hole or rabbit hole or some sort of area where she can make a nest, and then she starts her nest, starts provisioning pollen in the nest, and lays the eggs, and then that first generation starts to forage for her. And then it's throughout that season that the more and more eggs she lays, they are the independent workers. The colonies can get up to sort of 400 or 500 workers. And from that point on, the queen basically stays in the nest. And then through the year, the colony builds up, and the queen at the end of the year will die. She'll only live for basically a year. And then the males emerge at the end of the season. The females will mate. The males will die. The females will go off, find their overwintering site until the next season when they start all again. So that's the social bees. When it gets to solitary bees, things are, I guess, less social because they're solitary. Although sometimes social bees will they'll nest in aggregations. You might have seen the alkali bees, frigid alkali bees, or some other aggregate nesters where they'll nest together, but they're not actually working together. They'll typically nest together because of a certain soil type or something, or protection, but they won't work together for one cause. And so of all of these, roughly 90% are these solitary bees, where there's no division of labour. Many of them are flower specialists, so they live in areas where there's certain interactions that have evolved over many years, and they're specialists to certain flowers. So they're pretty important in a lot of systems from that point of view. And this one seeks to illustrate what the solitary bee life cycle is like. So there's the ground nesting bees, and then there's the cavity nesting bees. This is a picture of a mining bee, the Andrina, and its nest, and then the next slide I've got another one, which is a little more impressive. This just shows the life cycle. So the mining bee will find the right substrate, dig down. They will line the sides of the nest with some waxy secretions. They'll then work to provision the nest, collecting pollen and nectar, make these little pollen balls. They'll lay their egg. And they typically do this. I've got a slide a little bit further along. They'll lay their egg, and they do it in cells within the nest typically. That egg will sit there, hatch, and then it feeds basically on that pollen ball within the nest. The mother will do this until the end of the season, until there's no more resources around. Under the ground, then she'll go off and die. Under the ground, the larvae will eat until it pupates. Then it depends on the species, but the majority of them will basically sit suspended under the ground through the winter as a pupa, and then go through that final stage of development, emerge the next spring when the cues are right, and continue the life cycle over and over. And so this shows a ground nesting bee nest. And they can dig down 2-3 feet under the ground, some species. Some will even dig into rock, into sandstone. There's species of mining bee in Arizona and Utah that will dig into sandstone cliffs. Pretty amazing. And so as I said, they'll secrete this waxy coating on the inside of the tunnels there to make these nests waterproof as well. So they'll be able to resist some flooding and stuff through the winter season. And then when springtime comes, they'll emerge up and start the whole process again. Of these ground nesting bees, I'm just going to talk about a few examples here. We've got these little striped sweat bees, which are typically mid to late summer bee, or even into the fall in some parts of the country. Really good pollinators of things like apples and that sort of thing. This is a green-tailed sweat bee. Might have seen these on sunflowers around the place. They're just typically really small little bee, which we see them just because they're bright green. I think they're a wasp or something, but if you look a little bit closer, they've probably got a bunch of pollen on their back legs working away. There's mining bees. As I said, mining bees are the ones that